My name is Henrik, and today I want to talk to you about server-side rendering and why we broke the web. First, I'll introduce you to the problem with client-side rendering only, and after that I'll show you a solution, how I solve the problem using next.js, which is a framework that really solves server-side rendering and client-side rendering really well. So, what's wrong with client-rendered web apps in the first way? When a user comes to my app, the app responds with an empty HTML page. After that, they'll download like 10 megabytes of my awesome JS app. 10 to 20 seconds later, the user sees the first thing on my page. This is like the pattern we use when we're building client-only web apps. This has, in my opinion, many problems that are still not really solved. Most people say, okay, you don't need server-side rendering because Google is able to index our page on the client side. They use something like Phantom.js and can index our page. So search engine optimization is not anymore a topic. But there are other user groups on the internet that depend on your server serving HTML and not some crypted JavaScript code. One example is, for example, Open Graph. Many services who want to provide rich snippets to your page, WhatsApp, Skype, Facebook, they need Open Graph tags, and only some of them are able to index these Open Graph tags or the title of your page on the client side. So saying Google solved the problem of server-side rendering is not really true. But we in our community decided to say, okay, server-side rendering is a bit complex, and Google says we can index your page, so we dropped this part. Many of us are ignoring this, and I did many years. So my solution to that is next.js. Next.js is a minimalistic JavaScript framework that solves, in the first place server-side rendering by using a universal approach and React. So if we use next.js, what do we get out of the box? The first thing, of course, is server-side rendering. But also code splitting is a big issue in that part. Like, how do we split our code on the different routes or subpages of our app so the client doesn't have to download the entire app.js on the first request? The third thing it solves are client-side page transitions. If we have multiple routes in our app, and we do a normal page transition to another route, we are losing state. For example, in Redux, when you navigate to another route, the entire page gets loaded again, and our Redux store will be empty. So we need to reinitialize this. If we have client-side page transitions, this is not an issue anymore. I think the first big client-side page transition was something like turbo links in Ruby, but I'm not really sure. This is a bit different. We get out of the box a build system. We don't have to read tons of Webpack docs and Gulp docs and need 2 weeks to get started with our project. We can get started immediately. But if we want to extend this build system, we still can add our own Webpack loaders. So it's really extendable and it works pretty well. The build system is based on Webpack 2. So we get tree shaking out of the box, which solves the problems of 2 big bundles. In addition to that, they come with their own CSS solution, which is similar to styled components, but works a bit better with server-side rendering. But you can still disable this solution and use your own favorite CSS solution. So guys, let's do some live coding. And girls. And oh, here we are. So we want to start from scratch because I want to show to you that how fast you can get started using this kind of approach. So we're starting by yarn initialize. You can use npm, of course. So now we have a package JSON created, and now we need to install our dependencies. At first, we install the Next beta version. Next has evolved in the past month, and they are close to the 2.0 version, which we already use in production, but it's still in beta, so things may change. Then we need React. Next could have bundled React with their package, but the cool thing having React as a peer dependency is you can use Preact if you want, or something similar to React. And last but not least, I installed just for our demo isomorphic fetch. A ponyfill would probably a better way, but for simplicity reasons, I use this. So now everything gets downloaded. Hopefully the internet will do everything. Cool. We are all done. We have installed everything we need. Let's start coding. So we have a package JSON file. Next.js, in order to get started really quick, we don't need an entry file. Oh my God, just say that you can't see anything. So here we go. So we can drop the main entry point. Next.js will add this for us, but later we can do it on our own way. So we are still flexible on this. Let's add 2 tasks to get started. I think it's always a good convention to add some scripts. So first we add a dev task. Careful, this is getting really complicated. Done. This allows us to start a dev task, which will do live reloading, code splitting, and will compile our app in a really performant way. So if we have a really big app, we won't have to wait like 2 minutes until the bundle is built. Next, let's add the production task. We combine the build task and the starting of the server in one task. This is just for this demo. Wow, complicated. So now Next.js has one important convention. They introduce a new component. If you're familiar with React, you already probably know functional components, higher order components, DOM components. And Next.js adds just one more component. It's called top-level component. The top-level component is the component in our app that gets initialized at the top level. So if we call a route, this component is the first component in our app. We call these component pages. Okay. So let's create an index page. Here you can see it. Oh. So we are importing React. And for simplicity reasons, we use like a functional component. This component returns our nice hello world. Let's start the dev server. We are calling our script task from the package JSON. You could call next if you have it installed globally. Please ignore the deprecation warning. It's a Webpack 2 issue. It has nothing to do with next. Next listens on port 3000 for default, but you can change it if you want. So, awesome. We got our first page. Nothing special, you think. But this page actually rendered on the server. The initial request was rendered on the server. If we disable JavaScript, we get the same result. Nothing special, React DOM can be rendered on the server, so why is this guy telling us this? So, let's create a second route. Let's call it cookie. Actually, what I want to build is like a little app that shows you some cookie messages from these fortune cookies, if you know them. So we create a new route called cookie. All right. Let's check if it worked. There it is. If we navigate between these two pages, we're losing state. Nothing is special about that. But next.js helps us here. The first cool thing about it, they have their own router. Probably you'll think, why don't they use React Router 4? This stuff is awesome. But when you do server-side rendering, React Router 4 doesn't solve all your issues. Next is built so it doesn't need to know all routes in advance. And in React Router, you need to tell the app, inform every route of all the other routes. And that's pretty difficult. So let's import a link component from next. And link to another page. Since the link component, the href will be populated by the link component, we put the href to the link component. Let's do the same on the, oh, this didn't work, sorry. So, since we are on the cookie route, it doesn't make sense to reference the cookie route here, but the landing page. On the landing page, we just do the same for now. Of course, we need the link component. These two files are kind of isolated. This is, since we have these entry files, like in the good old PHP days, you isolate each route from each other. If you work in a big development team and your friend is putting Minesweeper on his route, for example, which may have a lot of code, he won't influence your part of the application, which is a pretty neat thing. So let's look what we just built. Wow, we have a link. If I disable JavaScript on this page, the page will be still completely functional. We'll fall back on websites like in the 90s. So this is a great way of progressive enhancement. The user, even if he has no JavaScript or a big latency, he can use your JavaScript app immediately. So JavaScript is not a real important dependency. Just for like small JavaScript things like a counter or so, they won't work because you need something like state management. But links and showing the initial content will always work. So if we open the console and we click this link, we get a client-side page transition. 1 second. I need to reference the right href. Click the cookie. The build system just received the request that the cookie route is not built yet, so he's doing it really fast. So he just built the cookie route. If we go back, the entire thing gets even quicker. Bam. We don't have a full page transition, but we could call this route directly, and we get just the code we need for this route. This approach comes with another nifty feature. We can use prefetching out of the box. Just add the prefetch param to the link component, and you are done. So when we now load this Hello World example, we first get an initial response with HTML. Then the JavaScript is evaluated and may put extra functionality to our HTML page. And after that, we prefetch the next page. So it's already loaded. When the user has read like the caption of our page, the next page is already there. So if I click cookie now, it's there immediately, which is pretty nice. We're not losing state. We just improved performance of our website. We used code splitting. We used common chunks. So common parts of the application will be bundled into a common chunks file, so we don't have to reload this on every route. Right now, I just showed you something similar to a static page generator. We haven't populated any of these components with props, and that's what's really interesting about it. So let's add that real quick. Okay, I'm cheating a bit. Oh. Instead of returning a functional component, we can return a normal React class. So right now, we are on the cookie route. So you probably all know this pattern. We create a React class, put a render method, and actually nothing has changed. Okay, we try to get some props, but right now the app doesn't have any props. So let's add them. Next.js adds one static method. Nothing more, it's just one method. It's called getInitialProps. In this static method, we have access to the request object if this component was rendered on the server. We have access to the response object, and if we are on the client, these objects are undefined. So let's check if we are on the server. Easy as that. In the beginning, I told you we need isomorphic fetch. Fetch, I hope you're familiar with this. It's like the new XML request. So the new way of using Ajax request. This API is not part of Node, but we can like polyfill or ponyfill this API. So we can call fetch and some external RESTful API from the client or from the server. So this is the universal part of our app. After we got the response, we'll return a JSON. We're using await here, so async functions. If you're not familiar with them and don't want to use them, you can just simply return a promise from this function, or just an object if you don't do any async stuff. After we fetched the JSON, we use destructuring here to simplify a few things. So please ignore these. They are not next specific. And we return the initial props. Let's real quick look at this cookie API. This is the response we get. We are only interested in the fortune part object, so we use destructuring to extract it. And we feed our top-level component with a fortune object. So we have access to the ID or the message. Let's check if we get a cookie. I love live coding. We don't need this right now. Here we are. I just loaded this route directly. In order to show you the advantages, I want to compile our new Next app in production mode, so you won't see all the build system specific stuff. This is not interesting to show the point. So, stop the dev server, start the production task or script. Start, yes. So this is now compiling our entire application and starting the node server to serve this. As you can see, we try to reference a route that didn't exist. Sorry for that. We could disable JavaScript now and the app will still work as expected. If we navigate to the landing page, we get a client-side page transition. Or a foo. 1 minute. We want to go back. This is where the error comes from. Just like to recap, we are showing like the props message there. So we get the props from the static method get initial props. Okay, just saw a spelling mistake. Please excuse me for that. So now we are calling the cookie route. What now will happen is we get the next route via Ajax. So the top-level component from the cookie route will be executed on the client and not on the server. This is just because of the client-side transition. This was really fast because we prefetched this route. So let's recap. In the network inspector. First, we called the localhost route, or the landing page, and after 9 milliseconds, the user could already use our page. He was able to immediately read some stuff. Then he has to wait another 4 milliseconds until the JavaScript functionality got loaded, maybe 5 milliseconds until he could use our route, like all the client-specific stuff. After that, the prefetching kicked in. We got the cookie page with an Ajax request, which took us another 6 milliseconds, and from that now on, we are done. But the cookie page needed to call an external API. You see it's some Heroku app. So that was called on the client now. We got the cookie informations, and that's it. So if we do this again with a direct request, so we don't transition to that route with a client request, we get the page immediately. And this is like really awesome, if you believe it or not. So let's stop live coding for now, and let's recap what we just did. So just a recap, we have like these 3 basic components, and next.js introduced like this new top-level component, which is similar to any other React component. It just adds the getInitialProps static method. So we just created a React app in a few minutes. We solved the complex problem of server-side rendering. We added prefetching. We added client-side page transitions and code splitting, which works on a big scale as well. Next.js comes with a lot of other features that you don't need to use, but you can use them, and it's really convenient to use those. First of all, as I already mentioned, the Webpack 2 build system, which is extendable. It comes with a server route handler. So if you just saw it looked similar to a static site generator, but if you want to use Express to do your routing, or you want to use Core, so you can use similar, literally every server-side Node.js framework. So you're not bound to any of these. Next.js has a lot of community examples, which will point you in the right way. So in the next repository, just take a look at the examples. What parts are supported? So one interesting example is the server-side caching example. We can actually cache our server-rendered web app. If we have a big web app, we can get there an additional extra performance boost by caching a server-side rendered response in some kind of cache like Redis, and get speed like in a static app. In addition to that, it supports state management libraries. The community contributed, for example, examples for React, for MobX, or you can use whatever styling library you would like to. So you're not bound to their styling solution. For example, with Styletron, PostCSS, Shallow, and many more. So I hope you got some insights into Next.js. Please take a look when you're at home, and I promise you it's really awesome because you get really fast and developing quite impressive web apps. So thanks a lot for your attention. If you have any questions, I'll be here around. You can ask now if we still have time, or we'll see each other on the conference. Thanks.